Use the properties of limits. We can only apply them if those limits actually exist. So on this page, there's a couple special examples of limit questions where one of the limits does not exist, so we have to use one-sided limits. So in this first problem here, if we try to use the property of limits, we would go ahead and do this. We should be able to take the limit as x approaches -1 of f of x, and then take the limit of as x approaches -1 of g of x, and just add the two limits separately. But if you notice on the graph, as I approach the limit of f of x from the left and the right, the limit is not the same, so this does not exist, and this also does not exist as well. Now, it doesn't matter that both of them don't exist. If one of them doesn't exist, then we can't actually just add them together, because you can't add something with that does not exist. So this is where we have to use the idea of one-sided limits. So in order to find the general limit of this whole thing, we actually have to look at the left and the right-hand limits separately. So I'm going to start with the right-hand limit. So I need to find the limit of f of x as we approach -1 from the right side, and then we're going to do the same thing as we approach -1 from the right side of g of x. So now let's see if these limits exist. So on f of x, as I approach -1 from the right side of the graph, notice we are approaching the value of -2. And then on g of x, notice as we approach -1, we are approaching the y value of -1. So the right-hand limit of f of x and g of x approaching -1 from the right side is -2 plus -1, which is actually -3. Now we're going to do the same idea as we approach -1 from the left side. So if I approach -1 from the left side for f of x, notice we're approaching the y value of -1. So this value is -1. And then let's look at the g of x graph, and we're going to approach -1 from the left side as well. And notice here we're approaching -2. So this limit is -3. So remember, the general definition of limits says if the left and the right-hand limits are the same, then the general limit exists. So this general limit is -3. Now let's take a look at another example where those may not be the same. So let's look at this one. So again, same idea. Let's go ahead and try to see if we can use the property of limits by just adding the two limits separately as we approach 1 of g of x plus 1. So we always start with just a direct substitution. So if I look at this graph, so limit as x approaches 1 of f of x. As we approach 1, it looks like the value is 2. As we approach, so this, if I plug in 1 for x for g of x plus 1, we're really looking at g of 2. So notice here, this piece does not exist. So because one of the pieces does not exist, then we can't use the property as limits, so we have to use the idea of using one-sided limits. So I'm going to go ahead and do the same thing that we did on the previous problem. So let's start with the right-hand limit. As I approach f of x from the right-hand side, and it wasn't really f of x that was the problem, but as I approach f of x from the right-hand side, approaching 1, sorry, not -1, your y value is 2. And then as we approach 1 from the right-hand side of g of x plus 1, again, it's really g of 2. Notice that y value looks like it's about, we'll just say it's 3. So this limit, as we approach 1 from the right-hand side, is actually 5. We can do the same thing as we approach 1 from the left-hand side. On f of x, the left-hand side limit is 2 again. And then as we approach 1 from the left-hand side of g of x plus 1, notice here we are approaching a y value of 2. So notice here, the right-hand limit as we approach 1 is 5. The left-hand limit as we approach 1 is 4. The left and the right-hand limits are not the same, so we are going to say the general limit does not exist.